So we're going to talk about solving quadratic equations. And you will see that it really just means finding the x-intercepts by hand, okay? By hand, manually, algebraically. Okay?
Good morning.
Stay with us. When you're asked to solve a quadratic, okay, you need to determine or find, right, the x-intercepts. And note that x-intercepts is the same thing as, we call them roots as well. X-intercepts are the roots. You will see why we call them roots, because we take the square root of, before we find the final answer, we take the root of our answer. That's why it's called the roots. Sometimes it's also referred to as zeros. Okay? And I want to add one more, also solutions. Folks, these all say the same thing. Okay? So if I ever ask you, find the roots of this quadratic, you should know ultimately that it's finding the x-intercepts. Okay? That's the main idea here. We have two methods of solving quadratics. Two methods. Okay? One of them is the quadratic formula. That's the one I'm going to start with today. The other one is using a graphing method. Okay? This will be using the TI-84. Okay? We're going to actually graph and then find the roots that way. Okay? But the quadratic formula is algebraically. That's the one I want to focus on today. So that's the joke of today. How does a baby parabola, what does a baby parabola eat? Quadratic formula. Right? Formula, baby string formula, anyways. So if you're given ax squared plus bx plus c, okay, so this is in general form. It has to be in general form, okay, like that. We can find the roots, again, that just means x-intercepts, by using the following formula. This one you want to add to your study sheet for sure. So here it is. X, as in the x-intercepts, is going to be equal to negative, whatever b is, plus or minus the root of the following. B squared, it looks a little scary, but trust me, it's all about plugging in and solving it. That's all that is to it. Okay? Make sure you have it exactly this way. And, because some students miss this part, okay, I'm going to make sure you understand. This whole thing is going to be divided by, like, from end to end. Okay? Not just the root, the entire numerator. So once you figure out what this is, you're going to divide it by 2 times a. Make sure you have that formula exactly that way written down. Note on this one, okay? B squared minus 4ac, which is, if you think about it, I'm going to use a different color here. I'm going to use orange. This part right here is inside the root, b squared minus 4ac. Okay? And that is called the discriminant. Yeah. So when you plug it in and you figure out what that number is inside the root, meaning the discriminant, or the b squared minus 4ac, if that is positive, right, if that is positive, this parabola will have 2 roots. or x-intercepts. Okay, for sure. If b squared minus 4ac, you plug everything in, and you get 0. Okay? So if that is equal to 0, you have only one root, or x-intercept. If it is negative, there you go, you will have, how many roots do you think if it's negative? No roots, okay, no x-intercepts. Because you can't take the square root of a negative, right? And so I would say all of this, including the quadratic formula, so on my study sheet, I would have nice and big quadratic formula, have the formula here, maybe highlight this and just have like an arrow to it saying that is called the discriminant. If, like, maybe even on your study sheet, if this is positive, 2 roots, 0, 1 root, negative, no roots, right? You can really make it compact on your study sheet, but you need to know all of this in conjunctions, right? You can't just, don't just have the formula without all of this in there, because you need to know that, okay? Okay. It has to be in general form though. I have to add that. It has to be general form. I will add another note. Let's go way up here. Way up to the very beginning here. This part right here, another note. If you're finding the x-intercept, what is y equal to in that case then? It's 0, right? So under all of this, I'm just going to say, hey, you have to understand that y is going to be equal to 0. So if your equation has a y in there somewhere, you're just going to turn it into 0 and then proceed to use the quadratic formula to solve for the x-intercept. So this is very important to add that. I'm going to give it a different color so that it sticks out. Okay? So now I've introduced the quadratic formula to you. I could probably spend a lot of time on showing you why this formula came to be that way, but that's not the scope of this lesson right now. It's just, this is how you would do it by hand. Instead of using y equals 2, y2 is equal to 0, right? That's what we do in our calculator for x-intercept. y2 is equal to 0, and then second trace, intersect. Boom, 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 we find it, right? This is how you do it by hand. If you took pre-cal and they can't factor it, then they would use this formula as well. So you're learning the exact same thing as in pre-cal right now. All right, let's go to page 21 and practice this. Okay. All right. Solve the following using the quadratic formula. You have to use that one. Okay. And so you're given an equation, and you will let, right, note y is equal to 0 here. So we just say 0 is equal to 3x squared plus 3x minus 3. Okay. I want you to remember a is positive, right? So I'll just make a note here. A is positive. Therefore, we expect something like this. And the y-intercept is 0, negative 3. Okay? Don't forget about that piece of information. That's very important, that you always know what does it look like on the background. We always want to know that. Next thing I want you to know is, state is that A is equal to 3, B is equal to 3, C is equal to negative 3. Okay, so you've got those. And now we're going to, for this one, I'm actually going to state the formula. X is equal to negative B plus or minus. I will explain the plus or minus in a bit. Okay. Sometimes I don't use the brackets, and that's okay, but I need you to understand that you're plugging in into the bracket. Okay. Let me zoom in a little bit. I think I can do better than that. So let's plug in. Negative, whatever b is 3. Plus or minus. B squared, so 3 squared. Minus 4 times a is 3. C is negative 3, so you have to watch out. The sign has to follow. Okay. All of that over 2 times a. So this is imperative that you show me that you're plugging in and that the values actually are going where they're supposed to go. This isn't the greatest example because everything is 3, right? So it's hard to tell where did you put what, but just go with it, right? If that's what I give you, that's what you do. Okay, so now let's clean this up. So I'm going to go, it's getting a little tight here, so I'm just going to say I'm continuing here. And that's going to be x is equal to, I can get rid of a lot of these brackets because negative 3 times 3 is just negative 3. And you go plus or minus root. Let's figure out what the what you get inside that root. If you want to make absolutely sure that you do this right, use brackets. Okay, type it in exactly the way you see it. However, this is a minus. This is not a negative, okay? This is a subtract. So if you need to make a note to yourself, otherwise you're going to get the wrong answer. Sorry, I can just do times 3 times negative 3. So, you know what? I think it's worth adding this to the notes. For you might benefit from that. So I'll just say for that one, I press this button. Okay. For this one, this is subtract. It's very important. So that minus that you have on your original formula is subtract, it's not negative. If you put in a negative here, everything here is multiplying, everything. Okay, so then you're going to get the wrong answer. So I hit enter there, and I get 45. And I don't know if you recall, this is called the discriminant, right? So you get 45 here. And let's finish the bottom here. 2 times 3, I think we can just use, we don't have to use the calculator for that. Okay, so I'll just make a note here. Discriminant, I'm going to have to redo that. I think I can make this smaller here. Save some space there. Discriminant is positive. I don't know if you can see that. You probably can't. There you go. The discriminant is positive, therefore 2 roots. So this is similar to cosine law. Remember in cosine law when you had a negative there? What do we know when you get a negative cosine, like that value, if it's an SSS? Then you have an obtuse angle. You can foretell that that's going to happen. Same here. We know that this parabola is going to have 2 roots. Okay? So root number 1, x sub 1, this is how we do it. Negative 3 plus root of 45. So see how the plus or minus is there? We're going to go plus to get the first root, divided by 6. We're going to get an answer there. x2, right, second root is going to be negative 3 minus root of 45. Okay, we use the minus here. Divided by 6. And we're going to get an answer there. So it's just, do you know how to use your calculator at this point? So grab your calculator and you go negative 3 plus root of 45. I would hit enter at that point, and then I'm going to divide it by 6. Okay, so I find the top, divide it by 6, at 0.62. And the second root, watch what I'm going to do. I'm just going to go copy paste, and instead of plus, I'm going to go subtract. Hit enter, divide that by 6. That's negative 1.62. So those are my two roots. Okay, in fact, I would like you to know that 0.620 is the point, is the first x-intercept, and negative 1.620 is my second x-intercept. Okay, so those are the two roots. Could you have confirmed that? Absolutely. You can actually graph this parabola. y2 is equal to 0, second trace 5. You should get the exact same answers for your x-intercepts on that graph. Okay? And now I'm going to show you that later on we will double check that. Okay. Maybe, I'm just thinking now, common errors, that's what I'm thinking of right now. If I go back to this one here on page 20, I don't know, I lightly just say subtract. Okay, not this one. Okay. Subtract, comma, not, don't go negative. It's a minus, it's a subtract. Here, same thing, plus or minus. Okay. Under subtract, maybe you can go minus. It's the same thing. Okay? Because if you don't, then the whole thing is going to be wrong. You're going to be very frustrated if you get that wrong. Okay? All right, let's try more. One more, and then I'll let you actually fly solo a little bit here. This isn't over. It's not after today you're going to be experts, but this is going to come up a lot of times. Okay? Example 2. 8x squared plus 5x plus 7 is equal to 3x squared minus 4x. What's going on here? Is this in general form right now? Is stuff on the left side and the right side of the equal sign not in general form? So we're going to have to rearrange to this format. Okay? We're going to rearrange it so that we have that format. So what I do is, I normally bring everything over to the left-hand side. Okay? So I'll say that this 3x squared, I'm going to bring that over to this side. And the negative 4x, I'm going to also bring that over to that side. So you end up with 8x squared, and the 3x squared, when it comes over, it's subtracting. So maybe I'll use a different color for that one. Plus 5x. The negative 4x is, right, this is negative on the right side. When it comes over, it will change the sign. So it's positive 4x. And the 7 is already there. And now that you've brought everything over to the left side, you end up with 0 on the other side. That's exactly what you want. 8x squared minus 3x squared, 5x squared. 5x plus 4x, that's 9x. And the 7 is just 7. There we go. Now that's what we want to see. Granted, the x could be gone, right? This could be just like that. That's okay. You're still dealing with a quadratic there. You could have no coefficient for the constant. C could be 0. That's fine. Okay. Let's state our ABCs here. A is equal to 5, B is equal to 9, C is equal to 7. And let's plug in. X is equal to negative b plus or minus. So at this point, you would probably just look at your study sheet and follow the formula. B squared minus 4 times A times C. All of that, the whole thing, divided by 2 times A. And let's clean that up. You're going to get negative 9 plus or minus root. And I know that the bottom here is 10. 2 times 5 is just 10. You just have to clean up your discriminant here real quick. Grab your calculator. 9 squared is 81. We already know that. Minus 4 times 5 times 7. And you get negative 59. What's up with that? No roots. So you get to stop there. Don't continue. Don't be like, oh, that doesn't work. I'm just going to get rid of the negative, right? And keep going like nothing ever happened. No, you got to stop there. No roots or x-intercepts since the discriminant is negative. That's it. We're done there. So sometimes that happens too. One more, and then we'll leave it. Okay. Look at this one. Doesn't look general at all, especially because there are brackets. So we gotta distribute. Okay, so we're gonna go 3x times x, and then we're gonna go 3x times 2. And the negative 3, we're gonna worry about that later on the other side. So we end up with 3x squared plus 6x is equal to negative 3. And yes, we're going to bring this over to the other side. So it's 3x squared plus 6x plus 3 is equal to 0. Plus 3, because it was negative, comes over positive. Come up with your ABCs. And let's plug in. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. I need you to show me this line where you plug everything in. From there on in, if you want to do the rest in 5 lines or 4 lines or 3 lines, I don't have a big problem with that. I'm going to clean it up a little bit. X is equal to negative 6 plus or minus root, so that this whole thing will just simplify to just one number. And all of that is divided by 6. What do you get? You get 0, yes. So 6 squared. I'm not using brackets right now because none of the values I'm entering is negative. That's the only reason why I'm not using brackets. Otherwise, I'd strongly encourage you to do that. I get 0 right there. 0. So either you pick up on it, right? Only one root. Because the discriminant is equal to 0. So you could go x1 is equal to negative 6 plus 0 divided by 6, because root of 0 is just 0. That's negative 6 over 6. That's negative 1. So you found the only root that is negative 1, 0. If you didn't pick up on it, you would have ended up with the same conclusion. Both roots are negative 1, 0. What does that mean about the vertex if there's only one root? The vertex is sitting right on the x-axis. That's what that is telling you, right? That's the only way to get 1, is if it's right, if the vertex is right on the x-axis. So this is not just an x-intercept, it is also the vertex. Okay? Note, vertex is on the x-axis. So the x-intercept is also the vertex. That's just a side. I always like to make things, I like to highlight them to you, that you're not just blindly solving. Like, I think you're pretty good at like plugging in, just right, you get your answer, move on. I want you to think what's happening here, right? And we know that it's pointing up because A is positive, right? So there's a lot of things we know without even graphing this already. Okay, I'm going to leave it there. I'm going to ask you to try pages 24 and 25. That's all I'm going to say now. Pages 24 to 25. Let me just clarify something before you start. And we're going to go for as long as we can. I don't know, I feel like sometimes the services go a little longer. If you go to 24 real quick, just come with me here so you're not like, huh, right? What's happening? Most of these require you to combine like terms and bring stuff over to one side. What are you going to do if there's a y there? They're going to be equal to 0, right? Like you just get rid of them. So I will do that for you because it's so satisfying. I do one of those. I go like an arrow through it and just say that's 0 because we're trying to find the x-intercept. So I did that on purpose. I threw in a bunch of y's in there just for fun, right? But really, they're gone. And then, so here you have to FOIL this side. You have to multiply it out like this. Then you bring stuff over so that you have all your terms on one side. Okay, once you've multiplied out and you got rid of the brackets, you bring everything over to one side and try to solve. Okay, go. Thank you guys. You were great.